So, chapter 1.
Sorry.
Chapter 1, Introduction to Web Development. This is just kind of a review of the first stuff we kind of learned in the HTML, CSS class. I'm not going to go too much into it. We don't really do any testing or labs or anything associated with it, but just a refresher, kind of know what's going on. Use Chrome to run JavaScript applications that are on the internet, your computer, or a local server. Use Chrome's development tools to find the JavaScript statement that caused an error in JavaScript application. Use an IDE or text editor such as VS Code to edit HTML, CSS, and JavaScript files. For using an IDE or text editor such as VS Code that lets you run web applications from it, use your IDE or text editor to run an application. Describe the components of a web application. Describe the HTTP requests and responses. Distinguish between static pages and dynamic web pages. Describe the use of JavaScript. Describe the EMCA script specifications. Describe browser support for the ECMA script specifications. This ECMA is going to be a new term compared to the HTML and CSS stuff. We'll kind of cover it here in a few. Describe the use of HTML and CSS. Distinguish between HTML5 semantic elements and the HTML div and span elements. Describe the use of HTML attributes, ID, class, title, for, and name. Describe the coding for these types of CSS selectors, type, ID, and class. Describe the components of CSS style rule. Describe the components of a URL. I'm not going to go in much detail on that. By this point, we should all know most of what this HTML CSS stuff is doing. If you don't, you can hit me up after this video and we can kind of review on it, what's going on with it. Again, just div and span elements, attributes, which is our ID, class, title, for, and name. For is for the labels and stuff like that for the form items. Describe the coding for the CSS selectors. Again, the type is the element, the ID, and the class. CSS style rule, of course, it's cascading. Starts external, embedded, and then finally inline takes precedence. And then the URL, universal resource locator. Again, the components of a web application, you got your computers, tablets, smartphones, they all hook to the internet. The internet then goes to a web server, which holds the files that you're searching for when you're out on the web looking for things. Terms related to web applications, client, that's you guys using the computers themselves. The web browser, web server, network, internet, local area networks, internet, wide area networks, internet service providers. Big ISP around here probably is Charter, maybe AT&T. I'm waiting for i3 to come around my neighborhood. I'm getting tired of Charter cutting out on me all the time. So, how a web server processes static web page, and we've gone over this already. It makes a request back to the server, web server with the HTML files on it, finds what it's looking for, brings it back to the web browser, shows you what you asked for, hopefully. If not, you'll usually get like a 404, which says it can't find the file. You'll get a 500 error, which says something's wrong with the server itself. So if you want to look into those errors, yeah, it's up to you. If you keep doing web development, you'll see them quite often, honestly, especially the 404s and the 500s. So you kind of want to understand what's going on when you hit one of those. Dynamic web page at Amazon just means you can do a lot of stuff with it. A lot more than a static. Static usually just holds data or information on there. Doesn't really do a whole lot. Not very interactive. Terms related to a dynamic web page. Dynamic web page, application server, database server, round trip, server-side processing. And again, your web browser makes that HTTP request out to a web server, depending on what you're doing. You may go to an application server. Most of the time the web server and application server nowadays are both just one server. And then again, it goes to the database server. Database servers almost always has its own server just for security and making sure if one thing breaks, it doesn't break everything kind of a thing. So you can still access a web server, but you wouldn't be able to access a database server if the database server went down. If the web server went down with everything on it, then you lose everything. Can't get any kind of return. So it goes and gets what it needs and sends it back. You guys will be doing a lot more of this when you get into the 3rd and 4th semester stuff. Round trip just means it goes from the web browser all the way through the servers, whichever one you're accessing, and then comes back to the browser itself. And server-side processing is when the server actually does some kind of work back in the back end, middle tier section, and brings it back with it. Page with image swaps and rollover. Unfortunately, you can't see it, but anytime you go shopping, usually you can select colors in that and flip over them, and it'll change the colors. You'll end up doing some image swaps and rollovers in the later chapter in the JavaScript part. So it's nice to understand because pretty common thing in web pages is doing those rollovers and the image swaps. How JavaScript fits into the architecture. Make an HTTP request. It goes back to the web server. That web server is holding your HTML files, your CSS files, your image files more than likely, and of course your JavaScript files. It goes to it, makes the call, it finds what it needs, and then sends it back to the web browser. Terms related to client-side processing are scripting language, which is like JavaScript itself. JavaScript engine, jQuery. jQuery is just a library for JavaScript. Kind of a shorthand way to do some things, but it's a dying language at this point. They got bigger and better things that are kind of taking it over. We will touch on it a little bit in this class because most places, if you go work, there's already old code that has been written, and you'll just have to go in and modify it more than likely a lot of times, or may have to rewrite it at some point, and you'll probably see some kind of jQuery out there with somebody's code. Like I said, when I worked for the Department of Defense, it took us, jQuery was out probably 3-4 years before they finally allowed us to start using it. And it simplifies a lot of things. And then client-side processing on the your end and not the web server side. 3 of the many uses of JavaScript and jQuery. You'll use data validation a lot with JavaScript. Image swaps and rollovers also. Slideshows, you will, but with Bootstrap doing slideshows and the carousels and stuff like that, you could probably use Bootstrap and have it do it instead of having to write it out yourself. But know that when you do use a carousel or a slider or whatever in Bootstrap, they are using some JavaScript on that back end part to get it to flip the images around and move and stuff like that. The versions and release dates of the ECMA script specifications. You see June 1997 they started it. That was 1, 2 the next year, 3 a year and a half later, and so on and so on. 2020 is the last time they updated it. June 2020, that's the version 2020. Fancy how they finally started naming it after the year instead of a version number. Some additions in the recent versions. ES5 allows you to run in strict mode. Strict mode just says you have to do it a certain way or it will not work. You have to declare your variables properly and stuff like that. Adds several methods that makes it easier to work with arrays and objects. Adds a built-in way to work with Java object notation, which is JSON. I was trying to think if we use JSON at all in C#, but I don't think we did use it in that. But I know you'll be using it in Mr. Gubmested's class in the next semester or two. ES 2015, which is ES6, adds several syntactic improvements that make code easier to read and understand, adds block scope and easier ways to work with classes, adds arrow functions, iterators, and promises for working with asynchronous code. I know we will learn arrow functions in here. I don't think we do iterators or promises in this class at all. Some additions in recent versions. Part 2, ES 2016 adds a simpler syntax for computation with powers. I know we don't mess with that in here. Adds a method to check if an array includes a specified element. Adds async functions that await keyword for working with promises. Like I said, we don't mess with that. Adds asynchronous iteration and adds more regular expression features. 2019 adds new string, array, and object methods, adds improvement to the JSON object. And finally, 2020 adds a new big int data type and adds new operators for dealing with nulls. As we get further into this, you'll see there's only a few data types in JavaScript compared to when we did C#, and they had many data types and you had to declare them all. Here it's a lot more simplified. I think you'll find this fairly easy with already having taken C#. Most of this stuff is just going to be kind of a review for you until you actually start typing it out and using it again. So browsers that support ECMA script, you can see Chrome, Edge, Firefox, Opera, Safari. I think IE is probably one of the few that don't. Just trying to look and see what exactly EMCA script means. It's a programming language adopted by the European Computer Manufacturing Association as a standard for performing computations in web applications. So that's what that EMCA script is. It's just a association for standardizing performing computers, web applications. So Chrome 79, Edge 79, Firefox 68, Opera 66, and Safari 12 and up. The URL for browser compatibility table, you can go out there and check it out if you really want to. Time of this writing, the features that EMCA script through 2019 are supported by all modern browsers listed here. Like I said, back in the old days, each browser did their own thing, and it could have been a pain in the butt to get some of this to work on some and not on others. There'd be times you'd have to know what browser specifically you were working on and running on to make sure it actually worked on it, and if not, you'd have to try and find some kind of workaround for it, and it got to be a headache. I think they're all finally getting on the same page and trying to keep up with each other. Like on the CSS, when we use that normalize to try and get all the browsers to kind of do the same thing as we're coding it out so we don't have issues and stuff like that. That's kind of what this is trying to do for us. HTML file index in a browser with no CSS applied to it. See it there. Link and style elements go here up in the head. Of course, we know that. You can put a script at the bottom of the page. The difference between putting a JavaScript call at the top of the page is it may try and run code before the whole page loads, and it may cause an issue. If you put it at the bottom, it'll make sure everything is loaded first and then try and run the JavaScript if need to be run. So kind of keep that in mind depending on where you need or how you need your JavaScript to run. Can either be up here in the head, oops, or down in the end of the, just before the body closes. Web page with CSS applied to it. Link elements, style sheet, we know that. Style itself set up. File name, email list.css. We're not going to go too much into this since we just got done with all the CSS stuff. The web page in the browser with JavaScript used for data validation. script element, HTML body element that adds a JavaScript. So you can see here, just like calling the external style sheet, we're calling a JavaScript one now, and it's just saying the source of it is the email list.js. JavaScript has the extension .js, so you know it's going to be a JavaScript file at that point. And you just call that, and hopefully all your JavaScript should load and run and work properly. Email list.js for the file. Here they do a document.query selector. We'll learn more about that as we start getting into these codes and stuff like that. The variable type, and like when we did the C#, our variable type, we had to give it a data type to tell it what it was. Here we're calling it a constant or a let for the most part. We do use variable, but they're trying to get away from variable because of the way it holds data in that when the page is loading. So you'll see const and let more often than not. If you go do some old coding, I guarantee you'll see vars everywhere. When I came in here and interviewed for the job, first thing I did was put a var in because I hadn't been keeping up with JavaScript in a while because I've been working on nothing but old JavaScript all my career. So seeing the const and let being used all the time was a little bit new for me, but you can see it. Const just means it's constant, just like we did in C#. We declared some of those variables as constants, which means the data on them ain't going to change. Got a let here. That's just saying it's a variable. Nothing special on it, just the way it loads in the page kind of a thing. Do the selector here. This is like an arrow function. It's saying get this document, go find the query selector and the type of selector it's looking for, and that selector again is like a class. You don't see the element used as much, but it'll be an ID class, something like that. So you can say they're looking for the element. Email 1, email 2, first name. This dot value here is getting the value from the text box, more than likely is what these are, getting the values from them. Checking to see if the stuff's valid. If the email is equal to an empty string, throw an error. And again, you can see if statements, else statements. This is all stuff we've done in C#, so this should be just kind of a refresher for you. The difference will be some of the wording with it, like the text content and stuff like that. But other than that, it's going to be pretty close to the same as what we were doing in C#. Checking the first name. If it's not filled in, throw an error saying that the valid is false. If it's false, it can't really do anything. Don't submit the form because it's not valid, kind of a thing. So this event.prevent default just keeps it from the default from happening. I think we used that in C#, did we not, at one time or another? The prevent default, I think we used that. The email list file, there's some more. Clearing the form, just puts empty text for clearing the form. It's changing some of the text back. If you look at the picture, they have the little asterisks there. If there's an error, those asterisks change the text. And this code here just makes them go back to the asterisk again, so it just kind of resets everything. Here's that arrow function more here that I mentioned. So what this does is this adds an event listener, this DOM content loaded. The DOM is a document object model, and that's what this whole page is kind of laid out with, is a document object model, DOM. So when you hear DOM, that's what they're talking about, document object model. And we'll get more into it here in a bit. It's just saying content loaded, so it waits for all the content on the page to load, all the DOM objects to load. And then once that does, it says, okay, now run our function and go do what this has to do. So once it loads, it should be able to click on the buttons. This add event listener, it's listening for a click event. And that's what it's doing here. And it's either going to join list or clear form. And then again, we have that set focus, and we had some focus stuff in C# when we did it. So like I said, a lot of this is just going to be a little bit of a refresher. Once we start typing and get into it, we'll see a few subtle differences, but not too bad. Primary HTML semantic elements, again, is the header, main, section, article, aside, nav, figure, and footer, all stuff we've been using so far this semester. Page is structural HTML5 elements. I'm not going to go into this. That's the browser. The CDN for JavaScript Shiv for the HTML5 compatibility. You can go look that up if you need. Div and span elements. Again, a div's a block element, span's an inline. HTML div elements for a JavaScript application. HTML span elements for a JavaScript. The basic HTML attributes, ID, class name, foreign title. HTML uses these elements. Here's that form. Here's that label with the 4 that I had mentioned earlier. An ID of email, a name of email. Stuff we've been doing so far all semester long. It's just HTML and CSS stuff right now. HTML in a web browser with a tooltip displayed for the text box. Linking the style sheet to an external style sheet. They have an embedded style sheet. Again, they're trying to get away from those inline styles, and that's why they don't have an example of it on here. Head element includes 2 style sheets. If we have 2 style sheets, which one gets applied first? Which one gets applied second?
They're applied top to bottom, right?
Yep. So the top one would get applied first. Once that's applied, they'd apply the bottom one. The bottom one, whatever style's in there, would take priority over that first one that gets loaded. So make sure you keep that in mind as you're putting your external style sheets in there. And that's why they call them cascading. You can always think of that like a waterfall cascading down. The styles cascade down through it. HTML, it can be selected by type, ID, or class. We know that. H1 is the type. Class is listed with the class, and the ID is listed with that ID. In CSS, what shows that it's an ID?
No, it's the pound.
Pound sign is the ID. Period's the class. And then you can see, got element by ID. One element by ID has that pound sign there. A couple elements by class has the period in front of them. CSS for a typical application. We're not going to worry about that. Cascading style sheet, style rules. We just briefly talked about that. Property declaration, property name, property value. 4 ways to run an HTML page that's on your own server or computer. We've been doing that with the live server feature that we've been doing. There's some other ways if you want to do it. From your browser, click Control-O, shortcut key combination, start to open command, then browse to the file. Live server's good enough. 2 ways to run an HTML page on the internet. You can enter the URL page in the browser's address bar, click on a link from a web page and load the next web page. Components of the URL, again, the HTTP protocol. The domain name is whatever it is, modulemedia.com. The path just means there's a folder in this. What's the word I'm thinking for? I don't know. In the domain or in the overall web called our work, and inside that our work folder is index.html. And again, anytime you create a web page, you want to start it with that lowercase I, index.html. That's what the browser goes and looks for to try and load a page. If you don't have that lowercase I, index.html, it's not going to find it. You're going to have to type in the whatever page that you have as your starting page. So if you have it, instead of index.html, you have home.html, you'll have to type out that http www.modulemedia.com/rwork/ and then type in home.html. By putting index in here, once you type in that rwork and put a slash, it should go find that index in your file and not have to type any more in after that. If you omit the protocol, the default HTTP or HTTPS will be used. If you omit the file name, the default document name for the web server will be used. The default document name is typically, and here we go with the index.html, default HTML or some variation. I would stick with the index.html. That's what you're going to see 99.9% of the time. If you have some site set up, you'll see, like, you'll hear commercials where the guy's like, go use my name out here and go to www.myproduct/gym/discount.html. That's kind of how you'd want to do something like that. That way you're telling them type that discount.html in there. If not, stick with that index, and then the browser goes and finds it and sets it up right away and stuff like that. So 99.9% of the time it'll be that index.html. Chrome with an open console panel that shows an error. We look through that a lot of times in the HTML CSS part. When we start doing these JavaScript files, you'll be using this F12 a lot, the developer tools. You click on a button, you expect it to do something, it doesn't do anything. First thing I would recommend is opening that F12 developer tools up, go look at the console and see what's going on. Most of the time you'll see one of these little red errors like this saying something's wrong. Here it says cannot read property value of null, so you got a null value coming in and it's not expecting that. So it's causing an issue. So F12 developer tools, you'll be able to go find that stuff pretty quick out there. How to open or close developers tools, we've been using that a little bit already in HTML, so I'm not going to go into too much detail on it. How to find the JavaScript statement that caused the error, open the console panel by clicking on the console tab. You should see an error message along with the line of code that caused the error. See if they got it showing up here. Looks like line 6 here. Yeah. Email list.js line 6 is causing the error, so you kind of go dig through it, debug it. Click on the link on the right, and the error message indicates the line of code. This will open source panel with the portion of JavaScript code that contains a statement displayed and the statement highlighted. Back in the day when we used to debug JavaScript, before they had the developer tools and stuff for us, everything we put alerts in for everything. So like if you went into a function, the very first line would be an alert letting you know that you made it into the function. Step through a couple things and then you throw another alert in there to make sure you got down to that part of the code. Then you throw another alert, make sure you got down to that part of the code. Then you may have an alert with some values in it to show that your values are coming back properly. Now you can print it out to the console to see what's going on, have it come out to the console, or open that F12 and kind of follow along and see what's going on with it. So this developer tool, you'll be using it a lot in your coding time. Dialog box for choosing a folder in VS Code. We know how to do that already. We've been doing it with the HTML, CSS stuff. Know how to open a file, know how to open a folder, how to close a folder. Folder contains the folders for all the book applications. And that might be out in your repository. I think it is. Maybe. I know the slides are out there, so if you ever need these slides, they're out in your repository. How to add, rename, or delete a folder. We pretty much know how to do that, so I'm not going to go too much into it. VS Code, files in standard and preview mode. How to preview or open a file. How to close or save a file, add, remove. How to use the IntelliSense feature, problem window with an error displayed. See down at the bottom, like showing that error on your IDE on that Visual Studio code, so you can kind of go see what's going on with your error. How to identify them, usually has that red squiggly underneath them. Hover over it and it'll kind of give you an idea what's going on. Installing the Open in Browser extension. If you want to install that, you're more than welcome to. You just go to Extensions, install it. Rewrite the code with TypeScript. Now it depends on the library. Yeah, I don't think I would mess with that. How to install the Open Browser extension. If you want to, you're more than welcome to. I probably would not do it. How to open HTML file in the browser, and we know how to do all that. So that's just a quick introduction to JavaScript and the web. To actually start digging into it now. Getting started fast with JavaScript. So we're going to be off to a fast start now. Hang on. Objectives, given the specifications for JavaScript applications that requires only the skills you've learned so far. Code, test, and debug the application. Describe 2 ways to include JavaScript in the body of HTML document. Describe how case sensitivity, semicolons, and whitespace relate to the syntax for a JavaScript statement. List the primary rules for creating a JavaScript identifier. Describe the use of JavaScript comments, including commenting out portions of JavaScript code. Describe these 3 primitive data types that are available from JavaScript: numeric, string, and Boolean. We'll probably be using those more than anything, and you can see how primitive or generic this is compared to C#. C#, it wasn't just numeric, it had to be integer, decimal, float, something like that. Strings were strings, and then Booleans were Booleans, but the numeric is the big difference. You don't have to tell it what kind of number to use thing. No, we don't have to worry about it being a decimal or a float, integer. It's just numeric on this. Describe the use of variable and constant declarations and assignment statements with numeric, string, and Boolean data. Distinguish between using let and const keywords to declare constants and variables. And using the var keyword to declare variables and constants. Describe the use of arithmetic operators and the rules for evaluating arithmetic expressions, including orders of precedence and the use of parentheses. Again, a lot of this is just going to go back to our C# days. So as we talk about this, you'll be like, oh yeah, I remember this in C#. Jason, hopefully you can stay awake for it. I know this is fun stuff for you. Distinguish between using the plus operator and a template string literal when working with strings. Explain how to use an escape sequence such as /n to include a special character in a string. Describe the syntax for referring to a method or a property of an object. Describe the use of alert, prompt, parseInt, parseFloat, write, and 2 fixed methods. Again, you see that parseInt. We did some of that parseInt and parseFloat stuff in C#. All these are considered what? You know what?
Methods.
Yep. Why is that?
We can get the parentheses between alert.
Yep, because yep. So that's the name of the method, and that's just telling us there's no parameters being passed back to it. So nice. Glad you remembered that. So, and it says there methods even. Did you know that? Is that what gave it away?
I wasn't paying attention to that. I was
Yeah.
more curious about, okay, so this to fix it method, what is exactly that doing? And along with that alert and prompt. Now I know the parseInt, I kind of remember what's it kind of doing, but I really just know like it's probably the same thing as that try-parse or 2-parse.
Yeah, and we'll get more into that as we go through these slides. But the alert, the write, prompt, you'll use those quite a bit when you get in the real development. In our labs, I should say, you'll use the alert, prompt, write stuff, maybe 2 fixed. In the real world, you'll be using all these at some time or another when you start doing real development. So 2 types of attributes of the script element. you have the source and the type. And you can see down here, the source just says the file that you're going to use. And normally there's a type and it says JavaScript just to let the browser know that's what it is. But script element in the body section that loads an external JavaScript file. So you just say script because it is a JavaScript. So script short for JavaScript. Then the source, and again the source is that file, the JavaScript file that we're going to use. Just like the CSS used that source or the image used the source, the script, the JavaScript is going to use that source to tell it what JavaScript file to go access for us. A script element that embeds JavaScript in the body, and just like the CSS, when we embedded that CSS in the head part of the thing, you can do it in the body with JavaScript. And so you can just put the keyword script, close that script tag, and then put your JavaScript in there like that, and then it'll still run when it gets to it. Here you can see they're using an alert. The alert just pops up a window telling you this. Here they're doing a prompt, and it's asking you to put some numbers in. Another prompt telling you to put how many gallons in. Yep. So, like I said, a lot of this is going to look familiar. Here's that parse float, parse int, and then they do an alert where they do these miles per gallon. So you'll see text called miles per gallons on there, saying miles per gallon. And then this is the variable down here. So they declare this let mpg. It does the math here, takes this mpg, does a parse float on it. And then when this alert pops up, you'll see miles per gallon, and this MPG is just pulling the variable, the value out of this variable here and populating it in that alert box. That's kind of what we did in C# when we put stuff out to the window, when we did some of the Windows Forms applications and we declared showed a value onto the window itself or whatever. That's kind of how we were doing it there. Terms related to including JavaScript. You have an external JavaScript file or an embedded JavaScript file. There is no inline, not like the CSS and stuff like that. There is no inline for JavaScript. It's just external or embedded. I would try and keep as much of it external as possible. Keeps your code clean. That way you know where everything is. You can go look in the file and find it instead of having to dig through your HTML code and all that to try and find some embedded JavaScript. HTML page with two no script elements. So you can see they have this no script tag here, open, close. That no script is saying if for some reason your browser does not allow JavaScript, run this code here in between these no script tags to show them that, hey, you're not running JavaScript, go turn it on, kind of a thing. They do have it on, it'll go down and then it'll do the document.write and do the date string stuff here. And again, they have this no script, and because if the JavaScript was turned off, it wouldn't be able to run this script here. So they're just telling them today is the first day of the rest of your life and not printing out the date or anything like that since it doesn't work. The page in a browser with JavaScript enabled, you can see how it had the date. Here it is without it disabled, and you can see the notice here: to get the most from your website, please enable JavaScript in your browser. That's exactly what they're telling it here with an H2 tag saying, hey, to get the most out of this, turn JavaScript back on. And then since they do not allow that JavaScript script to run in the example, they put that today is the first day of the rest of your life. Here's that today is the first day of the rest of your life. Since they have it turned off, it can't run the date part of it, so it throws this no script notice here. I don't know many people that disable it anymore. Back in the day, some people were scared that it was hackable and did not want to run it, and viruses and this and that, and issues with it, so some people would turn it off. Now with the standards and everything being set, it's a lot more safe. To turn it on and off, you can go out to a browser. Whoops. Out to a browser. You click the little menu thing up here. You go to settings. And then you can go to privacy and security, down to site settings, and here you can see JavaScript. Site can use JavaScript. You can turn it on or off. You can let it run or not let it run. So if you are working on a computer or helping somebody build a website or doing something at work and you're having issues with JavaScript, you might want to go check their settings and make sure they do allow JavaScript. But like I said, very few people turn it off or don't allow it anymore, so you shouldn't run into that too often. The basic syntax rules for JavaScript. JavaScript is case sensitive. Each JavaScript statement ends with a semicolon. JavaScript ignores extra white spaces within statements. So if you're writing out code and put 50 spaces in between something, it's going to ignore those spaces. And then when JavaScript is in strict mode, it disallows certain JavaScript features and coding practices that are considered unsafe. As we start doing this, I know a lot of the labs tell you to run it in strict mode. I would try to get in the habit of doing that just to get you to code better, get your code to run a little bit more safe, have less issues with it. So here, they're creating a function called join list. The first thing they do is run this use strict, and it is a string, so you put it in double quotes or single quotes. A string in JavaScript, you can run double quotes or single quotes, but whatever you open it with, you need to close it with. So if you start with double quotes, you have to close it with double quotes. If you start it with double quotes and close it with a single quote, you'll get an issue. So here they call this use strict, and then they're creating a constant called email address 1. They're going out and getting the value out of the text box of email address 1, email address 2, and first name. And again, we looked at this earlier in that first set of slides, I believe it was. If statement, checking to see if there's an email address in there. If not, it's saying required, same 2, and it just goes through like that. They don't really have any validation on this one. I guess they kind of do because they're throwing alerts to tell you to put the stuff in, but it looks like you could probably still submit it without too much validation on it. How to split a statement over 2 or more lines, and we did some of this in the C# when we were like, line was getting too long and you put the plus sign and then start writing on the next line down so it knew it was staying together. So split a statement after an arithmetic or a relational operator such as a plus, minus, multiplication, divide, equal, equal to, greater than or less than sign, and opening brace, which is like the if statements. Here, it's got a opening brace, so they break the line and put it down to the next one. A bracket or parentheses or a closing brace. Do not split a statement after an identifier, and an identifier, all the identifier is a variable name. So in C# we called it a variable all the time. Occasionally I called it an identifier, but when you see the word identifier, that's all it is a variable name. A value or the return keyword, a closing bracket or closing parentheses. And you can see here they have closing parentheses. It's still on the same line. They have that opening bracket, then they finally break it and have it drop down to the next line. I don't see any returns or anything in there. Rules for creating identifiers, and again, like I said, identifiers are just variable names. Identifiers can only contain letters, numbers, the underscore, and the $sign. Identifiers cannot start with a number. Identifiers are case sensitive. So if you say cat with a lowercase c, but you call cat with a capital C, you will get an error because it is case sensitive. It's looking for that lowercase one. They can be any length that you want them to be. Identifiers can't be the same as reserved words. Reserved words are like write and alert and stuff like that, the keywords that JavaScript uses. You could probably go out and search the net and find a list that's 20, 30, 40 words deep. Let's go. So you can see list of words that you shouldn't use as a variable name or an identifier. These are keywords that JavaScript looks for its code. Valid identifiers in JavaScript. Subtotal starts with a capital S, so if you're going to use subtotal again, it's going to have that capital S on it. If you use lowercase subtotal, you'll either get an error or it's going to be a different variable name. Index _1 is valid. This $sign is valid. I hate that single $sign by itself like that, but some people use it as an identifier. Tax rate. This tax rate is camel case, and again we use camel case in C#. Camel case, the first letter is lowercase, the first letter of the second word is capitalized, and so on throughout the word. So if we put like the word cut behind tax rate, cut, the C would be capitalized and tax rate to keep it going as camel case. This calculate _ click, this is considered snake case. You can use it either way you want. I would say once you start using it one way, so if you start camel case, keep going camel case all the way through your code. If you start snake case, keep going snake case all the way through your code. And then you can see here they're using this $sign with the word log behind it to show it's a valid identifier. jQuery uses the $signs a lot like that. Like I said, I hate those $signs. Camel casing versus snake casing, we just talked about that. First letter is always lowercase, the first letter on the second word is always uppercase, and so on, depending how many words you use for your identifier. Snake case, it just puts the underscore in between the words is the difference on that, and no capitalization. So once you start using one, stick with it. Don't keep switching back and forth. Naming recommendations for identifiers. Use meaningful names for identifiers. That way your identifiers aren't likely to be used or to be reserved words or global properties. Be consistent. Either use camel casing or snake casing to identify the words within your variables in your scripts. If you use snake casing, use lowercase for all letters. And then here's the list of reserved words in JavaScript. So 1, 2, 3, 4, about 40. 50 of them or so. JavaScript code with commented highlights. So if you comment something out in JavaScript, you can do the /* and then end it with the */. That comments out a big block of text. So if you want to comment out a lot, that's what you use. If you just want to do a single line at a time, you can use the 2 / there, and that will comment them out. Kind of like some of the CSS, definitely like the C# we had been using to make comments on your pages. If you're doing a lot of different things on there, I would recommend using comments as much as needed. Don't go crazy with it though. Basic syntax rules for JavaScript comments. Block comments begin with the /* and end with the */. Single line comments begin with 2 / and continue to the end of the line. Guidelines for using comments. Use comments to describe portions of the code that are hard to understand. Use comments to disable portions of the code that you don't want to test, and don't use comments unnecessarily. Terms related to JavaScript syntax: statements, white space, strict mode, identifier, camel casing, snake casing, comment, and comment out. We kind of covered all of those. JavaScript's primitive data types. Got number, string, boolean, symbol, null, undefined, and big int, which just came out in that ES 2020, so about 4 years ago now. The ones you'll work with most will end up being number, string, boolean, null, and undefined more than likely. Null, you might need to check for null values or set something null to have it do something that you want it to do. And then undefined just means it's undefined. You may be trying to call it before you declare it and initialize it. And so you'll probably see that in that case. Boolean is just true, false, yes, no, 1, 0. Again, a string is a string and a number is a number. Examples of number values: 15 is an integer, negative 21 is a negative integer, 21.5 is a decimal, negative 124.82 is a negative decimal value, and negative 3.7e minus 9 is a floating point notation for negative 0.000037. The number data type: a number value can be any integer or decimal value. So that's why I said this is a little bit easier than the C# because you don't have to worry about the data type necessarily because that number can handle them. In JavaScript, decimal values are stored as floating point numbers. If a result is stored in a number data type that is larger or smaller than the data type can store, it will be stored as the value infinity or negative infinity. If it gets to that big int should catch most of that. Examples of strings. String, JavaScript, anything in double quotes or a single quote is going to be a string. So JavaScript here in double quotes is a string. String data in single quotes is a string. And then an empty string is just blank, no value to it. So like I said, if you start it with double quotes, make sure it ends with a double quote. If you start it with a single quote, make sure it ends with a single quote. String value is surrounded by double quotes or single quotes. The string must start and end with the same type of quotation mark. An empty string is a string that contains no characters, that is entered by typing 2 quotation marks with nothing between them. Usually you'll see that on your text boxes when you don't want a value in there at the time and stuff like that. 2 Boolean values: true or false, equivalent to true, yes or on for true, false is false, no or off. A Boolean value can be true or false. Boolean values are often used in conditional statements. It's kind of like our ifs and stuff like that, or valid statements, is valid kind of thing. How to declare and initialize a variable. And again, the variable and identifier are kind of interchangeable. So if you see that word compared to identifier, it's pretty much the same. So they're declaring a let, and then the variable name, and giving it a value. So they're doing let, giving the name count, and giving it the value of 1. Let, name subtotal, value 74.95. Again, a let with the name, Joseph, let email, they're leaving it blank. Let is valid equals false. Let total equals subtotal. Let x equals 0, y equals 0. Declares and initializes 2 values. How to reassign the value of a variable. And we've done this in C#, so declare a let, give it the name count, assign it the value of 1, take your variable name count and then take that count and add 1 to it. So you start out at 1, your count is at 1, you add 1 to it, now your count is 2. How to declare and initialize a constant. So instead of a let, now we use this word const, C-O-N-S-T. Give it the name you want to use and the value you want to use. Same as for variable, but with the constant keyword. So here they do constant, give it the name count, assign it to 1. So then they try and take that variable count and take that 1 from the count value and add 1 to it. Well, it's going to throw an error because it's a constant value. You're trying to change a constant value and that's not allowed. So you get this type error, assignment to constant variable. So to get that to work, we'd have to take it from a constant and either make it a let or a var to get it to work properly, because these constants do not want you changing these values once they're set. How JavaScript processes variable and constant declarations. JavaScript places all variables and constant declarations in memories first. This is called hoisting. When a variable that's declared with the var keyword is hoisted, JavaScript initializes it with the value of undefined. Because of this, you can access the variable before you declare it, but its value will be undefined. When a variable that's declared with the let keyword is hoisted, JavaScript doesn't initialize it. That's also true of a constant. Because of this, you can't access the variable or constant before you declare it. So with that var, if you use var and you try and use it before you declare it, it will return a value of undeclared for you. You don't necessarily want that, or I should say undefined. You don't necessarily want that because it's just saying you're trying to call it, but you haven't defined it yet, so it's not going to work properly. It's not going to hold a value or have a value for you. When you use the let or the constant one, it doesn't initialize it, and because of that, you can't access it. It does not give you an undefined return or anything like that. You just cannot access it. So it's a little bit of a difference between those two there. Like I said, they're trying to get away from that var keyword, but I guarantee you if you go look at any old code, and we could probably go look at some of the websites out there now, and you'll see var used everywhere in JavaScript just because that's the way it was done for so long. Let's see what we got out here. Trying to find a normal website. So let's go to page source.
Wow, that's gonna be because not cheap themselves.
Yeah.
JavaScript that's being used.
So here they're using a constant. Here they use a constant. And some of these, like CNN, which they probably keep up pretty good on their stuff, might have the time and money to go through and clean a lot of that up. Let's see. I know government-wise, there'd probably be tons of them in there because they don't want to spend the money to fix something that's already working. Let's see if we can find it in here. Here's try catch. We saw those in C#. Seeing much in this code. So let's do see if we can find a var. So there 1,027 of them showed up in this code. So that's not all these are though. So it's not finding strictly what we're looking for, but so here's a var right here. They're saying var domain. So you can see they're out there. So if you come across them, don't be surprised. Variable declared with the var keyword, accessed before it's declared. So if you do an alert and you try and call this variable val before, or I guess it's is that val or val1? Can't tell. Before it's declared, it gives you this undefined value here. If you do it after it's been declared, so we declare it, now we're trying to access it, you can see it will display the value string that we have assigned to it. And then if you do the let, you try and access it before you declare it, you get this reference error, nothing displays because it doesn't access it at all compared to the var. The var will access it and give you this undefined. The let will not even access it, so it doesn't show anything because of that. After you declare it and then call it, and then it's going to show you the value there. Value. So that will show that there. So that's kind of the difference on how those two work. The constant's the same way as the let. So just kind of keep that in mind. But you should try and stay away from using var if at all possible. Terms related to variables and constants. You got variable and a constant, declare a variable or a constant, initialize a variable or a constant, assignment statement, assignment operator, literal value, literal, string literal, numeric literal, hoisting, and temporal dead zone. And that temporal dead zone is just the way the lets and stuff work and get called on there. Temporal dead zone is a concept in JavaScript that relates to the hoisting of the variables and the visibility of variables declared with the let and const. In the TDZ, a variable exists but cannot be accessed until it is not declared. So just kind of what we covered over whether it's going to show or not show. The arithmetic operators, same as we looked at in C#. You got your addition, you got your subtraction, you got your asterisk for multiplication, the / for division. Got that modulus that we used in C#. Divides the right operand into the left operand and returns the remainder. It's just looking for the remainder. Increment it, adds 1 to the operand. Decrement it, it subtracts 1 from the operand. Same as we did in C#. Order of precedence for arithmetic operators. So left to right, everything moves from the left of the screen to the right of the screen. So increment the operator first, then decrement the operator, then do multiplication, division, and modulus, and then finally addition, subtraction. Anything inside parentheses, and it talks about it down here, anything in the parentheses is done first, and then anything outside the parentheses is done second. So some examples: 5 plus 7 is 12, 5 minus 12 is -7, 6 times 7, 42, 13 divided by 4 is 3.25, 13 divided by 4, 4 goes into 13 3 times, which gives you 12. There's 1 left over, and that's why your result shows up as a 1, because it's showing us our remainder and not necessarily how many times the number goes into anything like that. Counter plus plus just takes the counter and adds 1 to it. Counter minus 1 minus minus takes the counter and minuses 1 from it. Then we have 3 plus 4 times 5. Because of the orders of operands, is 4 times 5 is going to do first, which is 20, and then add the 3 onto it to do 23. Again, the parentheses go first, so this one will be 3 plus 4 is 7. Then you take the 7 times by the 5 and get that 35. 13 divided by 4 plus 9. The modulus is done first, so then because of our example up here, we know 13 modulus 4 gives us 1, so then we take that 1 from this part and add it to the 9 to get 10. Here we do the addition first because it's inside the parentheses. 4 plus 9 is 13. 13 divided by 13, or 13 modulus 13, is 0 because there's no remainder with it. It goes in there one time, no remainder, so 0 is the result you would get from that. And like I said, when I interviewed here, Mr. Gumstead had me using the modulus, and the 23 years I had worked coding, I had never dealt with the modulus, so it was kind of funny having to do it. It's like, I haven't used it since college 20-something years ago. Code that calculates sales tax. Here they have a constant called subtotal, assign it the value of 200. Another constant called tax percent, that's at 0.05. So then they do a constant called taxed amount. That taxed amount, they take the subtotal of 200, multiply it by the tax percent of 0.05, gives you a value of 10. Then they have a constant total, which is taking that subtotal and adding into the tax amount to it for a total of 210. And the reason this works is because this subtotal is assigned this value. They're assigned the values. These values don't change. Once you put these together and add it to that sales tax amount there, it won't change, and this total does not change. Even though we're using two variables to give it a number, technically it's not really changing. We're not changing that number. We're just, that's the way we're assigning a value to it. Code that calculates the perimeter of a rectangle, again, is a constant width of 4.25, a constant length of 8.5, and a constant perimeter, which equals 2 multiplies the width plus 2 times the length, which gives you 8.5 plus 17, which equals 25.5. So we're not technically changing anything with this constant. We're just assigning the value to it by doing a little bit of math kind of a thing. So even though it looks like things are changing with it, even though it's a constant, technically it's not. It's just doing some math to calculate a value to assign to that constant called perimeter. The most useful compound assignment operators is the plus equal, adds the result of an expression to the variable. Minus equal subtracts the result of the expression from the variable. And then multiplication equal multiplies the variable value by the result of the expression. This is all stuff we did in C# previously when we were doing some of the math ones that we used a lot of this. So statements with compound assignment operators. Let subtotal equal 7.95. Subtotal, again, which is 7.95, add 20 to it. By adding 20 to that 74.95, we get 94.95. Create a variable let, name a counter, equals 10. We're going to subtract 1 off that counter. And we do that. It goes from 10 minus 1 is 9. And then declare let with the name of price with the value of 100. Price times equal 0.8. That gives us a price of 80. Like I said, this is all stuff we've done in C#, so should not be too surprising or confusing for you. 3 ways to increment a variable by 1. Declare let, give it a name of counter, assign it the value of 1. Our counter, we do counter equals counter plus 1, so that takes that 1 in this counter here and adds 1 to it and assigns it to the counter, so now it's 2. The counter plus equal 1, since this counter is already 1, we're just adding 1 to it and saying the value, well, I guess technically it's 2 from up here since we're working down. So 2 plus 1 makes it 3. Since it's 3 and we're incrementing it 1, it's going to go up to 4. So, like I said, this is just a refresher, all stuff we've done in C#. A floating point result that isn't precise, and this is one of the problems you kind of run into with JavaScript, is you have a const subtotal 74.95. This const sales tax subtotal times 0.01, or 0.1 I should say, which then makes your sales tax 7.9500000001. When you try and compare these two numbers, they're two different numbers. So because that floating point isn't as precise as what we declared it up top at that 74.95, that can throw errors. And there's different ways of handling it. You can use like a number method and stuff like that to kind of clean some of it up. We'll get more into it as we go along with the chapters. When you do some types of the arithmetic operators with decimal values, the results aren't always precise. That's because decimals values are stored internally as floating point numbers. The primary problem with this is that an equality comparison may not return true. And again, this would not, because it's 74.95 and this one is 7.95, blah, 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 and goes on. Terms related to arithmetic expressions, arithmetic expression, arithmetic operators, order of precedence, and compound assignment operators. Stuff we just covered. Concatenation operators for strings. Again, this is exactly like we used in C#. That plus concatenates two values. So if we do the string this, and again the string has to be in quotes, so it'd look something like this. We could do this and then do our concatenator and put that, and our string would be this, that, because of that concatenator there. So just like C#, how we did it there. Concatenates the result expression at the end of the variable. We use this a lot when we're printing out values and stuff to get it to add to it and look nice. So that plus equal, I think a lot of them were lists, or we were adding numbers or something and it was coming up like that. So constants use the following examples, and this is constant first name of Grace, last name of Hopper. And the way they're doing it like this is they're both constants, first name and last name, so they can put them on the same line and say it's going to be a constant. And the first name is Grace, the last name of Hopper. How to concatenate string values with the plus operator. So then you can do constant name, take the first last name, concatenate it, put a comma in there, and then put first name back in, and then it'll show up as Hopper, comma, Grace. How to concatenate string variables with the plus equal operator. Let last name, or let name equal last name, which is Hopper. Take name, do the concatenator there, put our comma and a little space in there, and then we get Hopper, comma, with a space. We do that again with this name, plus equal first name, and then the first name comes at the end. So it's just concatenating all these together, but instead of being separate strings, it's just putting it in one long string. How to concatenate string variables with the template literal, and then you have constant name, and you have the tick mark there with the $sign last name, $sign first name, and the tick mark again, and you get name as Hopper, Grace. And we'll learn more about that as we start digging around in this JavaScript stuff, what's going on with that. Like I said, I don't like these $signs. They can get confusing at times. How to concatenate on multiple lines. You have a constant greeting called hello, constant price $15.99, constant is value true. So with the plus operator, and again, this just goes back to the stuff we learned in C#. You have a constant, name of message, and the value is equal greeting plus, and again the greeting we assigned it the value hello, so this should say hello plus, and then an exclamation point is the price really, a space, concatenating, just space concatenating. And this is where concatenation can get kind of ugly and confusing, because you have to keep using all these plus signs, all these quotation marks, and kind of spread them all out to get it to look right and stuff like that. So the message ends up being, hello, is this price really just $15.99? Answer is true. And you had to type all that out, all these quotes, all these plus signs, just to get it to look like that there. With the temperate literal, you do a message to, you do this $sign, and the greeting puts that greeting value in there of hello. Is this the price really just, and then again they're putting that price $15.99 in there, and then answer is valid. And that's kind of like what we're doing in C# and a lot of that string, I can't think of the name off the top of my head. You guys remember what we were calling it? Interpolation, that string interpolation that we're doing, to where we could put the $sign and the value of the variable in there to get it to show properly. And that's just kind of what this is doing with this $sign here, is just saying $sign, go get that variable and put it in there, $sign, go get that variable and stick it in there. So yeah, a little bit cleaner doing it that way than all this typing everything out with the plus signs and all that. Some of the escape sequences that can be used in strings, that /n starts a new line, doesn't affect the HTML, but does work with the text and alerts and prompts. Backslash single quotation mark, backslash double quotation mark, double backslash puts a backslash in a string. Some of these we used in C#, that new line operator there, we used that. I don't think we used the quote ones or the backslash very much in it. How escape sequences can be used in a string. So then you'll do alert. This isn't backslash single quote to get that apostrophe T in there. Is that what that's called, apostrophe T? The time to talk about this alert, the file is in the JavaScript // strings directory. And you can see you get the apostrophe T there and then the backslash in there. If we wanted to say this isn't /n, then we'd have one line that says this isn't, and then the next line down would say the time to talk about this. So like I said, we use that /n a lot in the C# class, so you should be pretty familiar with it. Some of the codes for Unicode characters, \lowercase u 00A9 gives you that copyright symbol, underscore or \lowercase u 00AE is a registered trademark, smiley face and the heart, and I believe there's more that you can use. They give us a list of them. No. And I'm sure we can go out on the internet and see. Let's see. Kind of hard to see on here, but they're using, like, there's the smiley face with the hard eyes. I don't know what Chinese symbol, I guess it is. Yeah, Chinese character, arrow up symbol, acrylic alphabet, copyright sign. Laughing face or tears. So you can see there's quite a few out there. Is it worth using? I don't know. I definitely know you won't use it in a job more than likely. So So some of the things you can do with the Unicode characters, kind of like the HTML ones we used. So here they're doing some Unicode characters in the alert box. Anytime you see this alert in the parentheses, it's just going to be an alert box. I usually click OK to close it. There's a website that lists them all. So you see they got quite a few of them. But like I said, more than likely in a real world, you're not going to be using those. Terms related to strings, concatenate, which means to join strings, concatenation operators, template, literal, string, expression, escape sequence, and Unicode characters. Template literal is just using that $sign and calling the actual variable name to get it to display in your text. Common methods of the window object. So again, now we're going to be talking about objects. The window object is the window, I guess you want to call it. There's a document object, there's a window object. The window object is pretty much what's in the browser. So common methods of that window object are alert and prompt. Alert just throws up a box with some data in it. A prompt actually lets you put some data into it. The syntax for calling a method of an object is the object name, the method name, and parameters. So like here they would want window.alert, but you don't have to put that window in there. You can just use this alert and it knows to do it that way. But so you know what's going on, you use the object name, and again our object is the window itself, so we do window.alert. That alert is the method name, and then the parameters or anything inside the parentheses that we pass through, whether it be a string, whether it be a variable, an identifier that we're using to show a value. So when you see the alert, that's what's going on. This would be window.prompt if you want to prompt the user for something. Here's a prompt dialog box now that we're talking about it. So you use a constant user entry equals prompt. This is a test of the prompt method. So this is the text you're going to see, and this is just like a hint type of value in the box there to show the user what they would want to put in there. You can hit OK, and then you pull the value out of that prompt box to use it at another time. One property of the window object, location. Syntax for accessing a property of an object is object name dot property name. So they're doing a alert dot window location. You don't use that too much in the real world. Two methods of the window object: parse int string, parse float string. This is going to be a big deal because as you're doing some of these mathematical things we're going to use, you got to know which one to use, int or float. I think we had issues like that in C# where people were mixing them up, and because of that their math values weren't coming out right. So parse int string, only the first number in the string is returned. Leading and trailing spaces are removed. If the first character cannot be converted to a number, NaN is returned. And that's what you're going to want to use some of that for comparing decimal values and stuff like that, to trim off some of the spaces and whatnot to get them so you can compare them. Examples that use the parse int and parse float methods. They have a let, entry A, prompt, enter a value 12345.6789, alert it, that's what it displays. They do this entry A, they're going to parse it as an int this time, and then alert it, and it cuts everything from the decimal point off, so then you only get 1, 2, 3, 4, 5. Here they're doing a parse float, so they enter 1, 2, 3, 4, 5, dot 6, 7, 8, 9. They alert it, it shows 1, 2, 3, 4, 5, 6, 7, 8, 9. Entry B, they say parse float that entry B, and because they're using this parse float now they're going to show what's with the decimal point. So they show that 1, 2, 3, 4, 5, dot 6, 7, 8, 9. Here they're going to try and do it with a string. They enter any value called hello, alert it, they're parse-inting the string, and because it's not a number, it's a string, you get that NaN, and we did see a lot of that NaN or whatever in C#. When we tried pushing some values like strings through parse-ints and stuff like that. So if you're trying to pass a string through a parse-int or a parse float, you'll get that not a number. NaN means not a number. So if you see that, that's what it stands for. Same examples with the parse method embedded in an alert. So instead of a prompt, they're just putting in an alert, and it does the same thing. The parse int gets rid of the decimal spaces. Parse float shows the decimal places, and the string parse float or parse int is just going to break and display not a number because you're not putting a number in. Pretty simple. Method of the document object, and so the document is actually the page itself. It's your document, so you can do this document, and you can see here they're doing a document.write. So this document is the object name, it's the object, the document, and then .write, it's saying write to the document. The alerts, you don't necessarily need the window on. This document.write document you'll be using a lot because we're going to do like document get element by IDs and stuff like that. So you can get in the habit of doing that. So they're saying, got a script here, they're putting the date, they're going to write today's date to a date string, and they're going to write it out onto the document. And down here they're doing another document.write, and they're putting a copyright sign on with the full year. So if we go look at this, you can see they're doing a document.write, it wrote today's date. So here you have your paragraph that says today's date is. Here's that part of the paragraph where it says today's date is. And then now we do this document.write. Today, whatever it is Tuesday, May 18, 2021. Got that next paragraph. Hope you enjoy our website. That's all in the main. Now in the footer, they have that script where they're doing a document.write, the copyright, and the year. And then there's that copyright with the year in there. So that's what the document.write does. It actually just writes it out to the page, to the document, to the page, and that's what that's doing there. Method of the number object, toFixed. This is what you were asking about the toFixed, Dominic, earlier. That's just telling you how many decimal points to use toFixed. And I think we used some of it in C# when we had some bigger numbers and we wanted to show like .00 for money or whatever, depending on how we were calculating the stuff. So here they have a constant of pi at 3.14159. We only wanted to show the first three things behind the decimal. So that's why we get the 3.142, and it rounds up to get that. So because that 5 is there, it rounds up to a 2, and that's why we get that 3.142. Terms related to objects. Again, objects, we worked with objects in C#. Usually have the object name and method that the object uses, and then the parameters we're passing to it. Method, property, calling a method, parameter, window object, global object, dot operator, document object, and number object. I think this is one of your labs or homework you're going to end up doing is this miles per gallon calculator. Have it print out. I think some of these you'll need your book because we're going to do a lot of labs out of these books. So make sure you have your book with you. Some of it's just code alongs out of the book in that, and then some of it you have to actually go look at stuff and manipulate it, whatnot. But there's the JavaScript for the test score files. And like I said, all these slides are out in your repository, so if you need them as a reference or anything like that, you can go ahead and grab them and flip through them. If not, I'd recommend reading the book. Try and keep up on that. You'd be amazed how much of a difference it makes by reading the book, especially before I lecture, and that just so you're prepared and all this makes a little more sense. But that's it for chapter 2, kind of an introduction to JavaScript. We'll start digging more into it Thursday in chapter 3, probably getting into the if-else statements if I believe and stuff like that. And like I said, this part's all review, and I think at the C# class, I think the students that took this in the fall and then followed it into the spring had a little bit of advantage because they had already saw working with variables and operators and this and that. It gave them a little bit of a jump over the first students coming in like you two, that was your first class and just getting kind of thrown into it. Jason, I know you had the experience already, and Dominic, this was new to you.
Yeah.
So I think the people that took this class first and then went into C# had a little bit of advantage, but only at the beginning, because once we started really getting into methods and passing parameters, I think that's where everybody kind of hit a brick wall and had to reevaluate their ability at that point, and then really start working hard to kind of keep up with stuff. So, but now that you guys already took C# and are doing it backwards, this should be fairly easy for you guys. It should be a pretty good review, and I know it's easy for you, Jason, and I hate to keep saying that, but I mean, these are just kind of introductory classes and stuff like that, so it should be fairly easy for you to fly through this stuff. So I'll stop the recording. I'll put it on YouTube today, and if you need it.